Well, hello there, folks. Welcome to, I believe this is my fifth live YouTube broadcast here. And it's kind of not a great night, but I was once again just sort of bored here and wanted to do something. So thought I would get out here and start streaming for you guys tonight. Going to get some background music playing for us, since that seemed to work out pretty well last time. But yeah, I will. I've already got everything set up, unlike last time where I kind of showed the whole process of everything getting fired up and all. Everything's already up and running, and in fact, I am already imaging. And I will switch over to our desktop here, and you can see, I'll make this as full screen as I can. You can see that I'm imaging the Andromeda Galaxy once again. This is a 15-second exposure that is live stacked, and if you look in the bottom left-hand corner here, you can see, or over where the cursor's at right now, we've got a total of 3 minutes and 45 seconds worth of exposure time. So that's pretty much what's happening right now. I will switch over to, let's see, we just had another 15-second exposure come in. So each exposure that comes in sort of darkens the background, reduces the noise, and it's really in a light polluted suburban area sky like I've got here, and especially on a night with a full moon. The only way to do long time exposures is either shoot with a narrowband filter, or to if you're shooting broadband, which I'm shooting the luminance filter right now, which is basically a clear filter, then you have to do really short exposures and stack them. Otherwise, a single 30 or 40 second exposure would just completely blow out this image. So we're looking at the Andromeda Galaxy. This is our nearest neighbor galaxy, aside from our own two satellite galaxies, the large and small Magellanic clouds that are visible in the southern hemisphere. But this is our nearest galaxy. It's 2 million light years away. So the light left this galaxy 2 million years ago, and it's just now hitting the sensor here, which is a pretty cool thing to think about. And I'm going to sit here and fool around with the histogram here and see if I can maybe get the background a little darker and bring out a little more of those dust lanes. It's really a cool galaxy. Not the greatest night to be shooting Andromeda Galaxy here, and I'll show you why. I'll switch over to my planetarium program. So here's the moon. You can see nice and bright. Getting the red line is the meridian. That's the imaginary line between north and south. And over in the upper right hand side here, you can see the Andromeda Galaxy. Oh, I kind of got twisted around here. Anytime you see kind of the orange crosshairs, that's telling us where the telescope is currently pointed. So if I zoom back out and try to get the moon and Andromeda Galaxy in the shot at the same time, you can see they're not super close, but when you have an 86% waxing moon like we've got tonight, it's a lot of reflection coming out of there. My favorite target that I just recently discovered, not really discovered, first time I ever imaged it, was the Rosette Nebula. And the Rosette Nebula is just behind my house over here right now, but you can see that it's very, very close to the nearly full moon. The moon will be full in 4 days. So not a great night for imaging in broadband in the suburbs, but I didn't have anything better to do, so just thought I'd chime in. If you're watching on YouTube, well, that's the only place you could be watching, because that's the only place I'm streaming right now. Drop a message in the chat. Let me know you're here. That way I know that I'm not just completely talking to myself. I do have a laptop open with just the chat window so that I can kind of keep an eye on things. Be nice if we had actual two-way voice communication, but with YouTube Live, I don't think that's possible. But anyway, I'm going to sit here, go back to sharp cap here, look at the moon for a few more, or look at the Andromeda Galaxy for a few more minutes. It seems like every time I shoot this target, and it only happens on this target, I get some strange banding. And I don't know if that comes across on YouTube or not. I'm going to go to 100%. It's a very weird pattern. You can see sort of like a line here and a line here. Maybe if I zoom out a little bit, it shows up even better. No, it's not really showing up that much right now. It might have gotten stacked out as we're pushing 7.5 minutes of exposure time here. Once again, you know, not a great night to be doing this. I was just bored again and wanted to do something live. If you have a suggestion for a target this evening, I will warn you, I have a very, very limited field of view. So this is Stellarium here facing south. And as you can see, my house is pretty, you know, blocks pretty much my eastern view. So the moon is cleared right now, but as we can see down in Orion here, the rosette that's in, it's not actually in Orion, it's in the constellation right next to it here. It is still behind the house here. And as I spin around, I'm clear overhead. I've got decent view to the north, a little bit to the northeast, and to the northwest, which is technically, I guess, where Andromeda Galaxy is right now that we're shooting. My view to the west is also blocked by my bushes along the backyard here, but I've got a better view to the west than I do to the east, that's for sure. So lots of little starlinks floating around out there. We can see a starlink going by here, a couple of starlinks actually. This is Starlink 1828 and Starlink 1714 passing through over our skies right now. I thought I saw one somewhere else towards the south here a few minutes ago. Let me just spin around and see if I can maybe get my eyes on that other satellite that was passing through here briefly. You know, in astrophotography now, there's a new term. Oh, this is a global star. I knew I saw another satellite here, but it's not a Starlink. But there's a new term in astrophotographers now called getting starlinked. Oh, there's the other Starlink that's going down over here. So I knew there was another one. That's Starlink 1292 going down there. Anyway, but yeah, so in astrophotography, the term getting starlinked means while you're imaging and doing a very long exposure, having multiple Starlink satellites fly through your exposure and ruin that frame. Doesn't really, with modern software and stacking, we can get rid of most of the Starlinks and all the other satellites. You basically can't even shoot the Orion Nebula without getting a lot of geostationary satellites that seem to be passing or seem to be in that area of the sky. Let's see. What do you think about the music? Is the music too loud? Is it a good level? I'm kind of making a mental note here of where I've got the fader. I've got it at 50% in my streaming software, and I've got it at 50% in the Windows Media Player, I guess, which is just playing a edited track here. Let's see. What have we got going on? I would say we could shoot the Crab Nebula tonight, but that would be kind of ridiculous because we can see Crab Nebula is so close right here, so close to our moon tonight. That would be kind of pointless. I will go to the moon. I know everybody likes to look at the moon. We'll go to the moon and look at the moon live for a few minutes. I'll just go ahead and highlight it now, but I want to go ahead and close this exposure out. We're at 10 minutes and 11 minutes now of exposure time on the Andromeda Galaxy. See, when I'm zoomed out auto in order to see my entire sensor, I don't know if that horizontal banding problem is visible on YouTube, but it's very noticeable on my monitor here. I don't see it on my laptop that I'm monitoring the stream with, though, so I guess it's I don't know, and it only seems to show up on this target. It doesn't show up on any of my other targets, which is strange, but so we're going to go to about 15 minutes of exposure time on the Andromeda Galaxy here. So we got about 3.5-4 minutes left, and we will then switch over to the moon. We'll look at the moon for a few minutes, and just for grins, we'll switch over to the hydrogen alpha filter, and we'll go to the Crab Nebula, which is practically being occulted by the moon right now, and just to see how bad or if there's any visible, there will probably be a gradient, a pretty bad gradient in the image, meaning half of the image will be very light and the other half will be dark, and that would be probably from the reflection of the moonlight hitting the interior of the telescope tube. No comments yet in the chat, in the YouTube chat here, but if, like I said, if you're just joining in, maybe if you want to look at something live tonight in the sky, if it's visible above my house and above my trees, I will be happy to point to it for you. Do some electronic astronomy at your leisure here. Alright, we're coming up on, we got 13 minutes now of stack time on the Andromeda Galaxy. This is M31, Messier 31. We can also see M32, which is this little faint fuzzy ball right there. Looks like a little cotton ball off to the edge here. And then this is M110, M110. The final object in Charles Messier's catalog of 110 objects. So Charles Messier was a comet hunter in the 1700s. Telescopes were not that great back then, so a lot of things they looked at in the sky just looked like little fuzzy patches. In fact, if you looked at the Andromeda Galaxy in a very small telescope, it just looks like a little fuzzy patch. So what Charles Messier did was he kept a very, very detailed catalog of the location of these fuzzy patches. And what he would do is he would observe them on multiple nights. And if the object stayed in the same location relative to the stars, he knew that it wasn't a comet, which is the only thing he was interested in. He was interested in discovering comets, because the king would give him land for every comet that he discovered and named in the name of the king. So that's how the Messier catalog came to be. So we've got about 45 more seconds here before we move on, and we'll go over to the moon. So we'll go from a very, very faint subject matter here to an extremely bright subject matter. So if you look in the bottom right-hand corner, you can see that we're doing 15-second exposures here, and you see a countdown, counting down the time that's elapsed and how much time is remaining. And then that 14:30 will go to 14:45. So our next 15-second exposure here will bring this session with the Andromeda Galaxy to a close. What I'll do is I'll pause the image after it comes in and stacks the 15-minute mark here. So I'm going to pause that. I'm going to just do an auto stretch here, which tells the software to guess what the best exposure should be. And then I will fool around with a histogram here to try to either darken it up, and I always kind of over darken my background sky. I know I shouldn't, but It's a bad habit that I've got. So I like that image there. So then what I will do is I will go to save exactly as seen, and it will save that file. So there's my image. No processing done to it other than the stacking in SharpCap Pro. Let's see what's going on here. Okay, give me 1 second, guys. I'm in the middle of answering a text message here. Sorry about that. All right. So this is my finished image. Of course, when you save a processed image in SharpCap like that as save exactly as seen, it saves it, as you can see by the little pop-up window there, as a PNG file. But that's all I'm doing tonight, just fooling around with different subject matter. So before we go to the moon, I am going to bring my exposure way down to like half a second here. And then I need to turn guiding off. The scope has been guiding all night, and seeing is horrible. And then I will go back to Stellarium, and I will tell it to go to the moon. And if I zoom out, let's see, where are we at? We should see the scope coming around here at some point in time. There it comes. You can see it coming. It made the meridian flip coming around from behind. We'll go back to the software and clear live stacking out. And as I suspected, our exposure is way too hot. So let me bring that down a little bit here. Okay, getting in the good exposure range here. All right, somebody's saying do Uranus, do Uranus. All right, we'll go to Uranus after we look at the moon here for a couple of minutes. I'm going to decrease my field of view size on the sensor here, which will automatically make it a little bit larger. And let's see if I move in the right direction. No, we want to go this way. Wrong way, Greg. All right, so there's a decent exposure on the moon. I might bump that up just a little bit, brighten up those edges a touch. And so that's a live image of the moon tonight, guys. Obviously, because of the rotation of the camera sensor in there, it's kind of turned at an angle. So if you just counterclockwise this about 45 or 90 degrees to the counterclockwise, that's pretty much what the moon looks like if you go outside and look at it tonight. So Loki, I will go to Uranus next, and it's not going to be much. First of all, I'm shooting with a monochrome camera, so everything I shoot here tonight is black and white. And it's also not a very long focal length telescope. We're only shooting at about 650 or 660 millimeter focal length. So it's really going to only appear as a faint little star in our frame. But I will happily spin the scope around there and point it out to you. I think what I want to do is maybe go to 100% here on the moon so we can see the moon's surface up close a little better here. Looks like my focus might be off just a touch, so I can tweak the focus. Let's go out 30. See if that makes it any better. No, that's getting worse. Let's go in 30. All right. So yeah, when you're doing fine-tuning, focusing on the moon, you want to always make sure you're looking at it at 100%. Ah, I know who Loki is now. I just looked down at my phone. All right, Tim, I see how you are. Okay. So we'll fly around the moon here a little bit. This region of the moon is probably one of my favorite parts of the sky to look at whenever I'm watching the moon live. You've got this very distinct sort of a C shape or a backward C-shaped crater here that's dug out of the mare here. And then you have a little straight wall of mountains, like a little short mountain range right there. And then you've got Plato, which is this dark oval-shaped crater. I believe this bright one in the center here is Copernicus. I could be mistaken on that. And then the bright one down here at the bottom, and you can see it looks almost like a starburst pattern coming off of this crater. This is one of the younger craters on the moon. This is Tycho, named after Tycho Brahe. We'll zoom out just a little bit so that we can get the full moon here in our frame. I wonder if we'll get lucky. The last time I streamed a week or so ago, we were sitting here and we were just looking at the moon like this, and we actually had a jet pass right through the frame, and it was very, very big because I live right under the flight path for McCarran Airport in Henderson, Nevada. And so when the planes are coming in here, they're very close, they're very low, and so it practically, if it had been, it sort of skirted the edge, about the right edge of the moon here, but had it been in the center, it practically silhouettes the moon. It was so big, but it was detailed enough that we could see the landing lights or the wing lights on it, because it was coming in for a landing at McCarran. So that was kind of cool. It kind of scared us, or it scared me anyway, because I wasn't really expecting that. I'm sitting inside the house, so I couldn't even hear the jet until probably 45 seconds after it went through the frame, when it was closer to the house. All right, I think we have looked at the moon long enough. Tim, do you I think named Tycho after The Expanse, the Belter's Tycho Station. Yeah, I believe not. I'm gonna have to call you. I'm gonna have to call your bluff on that one. Let's see, where are we at now? I'm thinking we're done with the moon. You know what? Just for grins, I'm going to hop over to the Crab Nebula and see if I can even get an image of it. It's not going to be much of a move. You can see the scope just hopped over to it there. I'm going to have to change over to a hydrogen alpha filter and bump our exposure up about 15 seconds. I'm going to change my field of view here back to the full frame of the sensor just for framing purposes. We'll see what comes in here in this 15-second exposure. Part of that is the moon. I don't think my frame, the Crab Nebula is actually that close to the moon that it would. I think it was moving during that 15-second exposure. So we'll wait for this next one to come in. No, it really is saying that it's that close. Well, we're definitely not going to be able to image the Crab Nebula if it's that close to the moon. I'm going to go back to our moon here just for a second. Go back to a super short exposure time. Go back to our luminance filter. And I am going to have to take a break here for a second, but I shall return. Alright guys, I'm back. Sorry about that. I had to step away for a minute. Nature calls. But anyway, let's see. What are we going to do here? We are going to, now that I know who's asking that question, Tim, I'm not going to Uranus. Okay? If you wanna look at Uranus, you know where to go. Let's see. Let's find something else to look at though tonight. We want to get away from the moon. So here's the moon. The Rosette Nebula is way too close to the moon. So let's go over to the northwest here and see what we can find. The Triangulum Galaxy is, that's M33. We could go to that. Watch my camera do a little meridian flip here. Get around to the other side safely. As you can see by the trees, got a little bit of a breeze out there tonight. Guiding is not guiding very well at all either. I haven't even bothered to turn off my landscape lights. That's why it looks like it's daylight out here, because all of my landscape lights are still on. I figure what little bit of light they add to the regular light pollution and the moon is not going to add that much more to any issues we've got tonight. All right, so we're looking at the Triangulum Galaxy now. We'll go back to our imaging software, crank up our exposure time to say 2 seconds and do a stretch, see if it's in the frame. May not be in the frame after doing a big meridian flip like that, although I think we're almost dead center there. So that's a good meridian flip, good tracking, but I'm going to do a plate solve anyway. Let's see what the plate solve comes back. .09 degrees off. Not too bad. Not too bad. So it's going to do a quick little bump and get it all centered up. And then we'll go over here and we'll turn guiding on. Start our guiding and clear all that data out from the last track. Now we will bump up our exposure time to, once again, 15 seconds. And start a live stack here. Clear. Oh, you know what? It's not subtracting the darks. So we want a 15-second dark, and we want a luminance flat, and we'll clear this and start that exposure time over again. Much better. Much cleaner. We can just make out the galaxy in the center here. Beautiful pinwheel galaxy. A few more exposures on it and we'll start really seeing a good bit of detail in the galaxy there. So Tim is asking me if I am using ASTAP. That you're talking about for plate solving, right? Let me see which one I'm using. The one that I have preset in here, you know what? I'm not. I'm using either Astro Tortilla or ASPS, All Star Plate Solve, I believe is what that ASPS stands for. And I think I've done both, and you know, this one is so fast. It just as long as the mount from CPWI is talking, and I've got the RA and deck here that coincides with the RA and deck of here where the mount is actually pointing, which is where is the mount actually pointing at? Where is M33? Is it here? There, yeah, M33. So as long as that number and this number are close, then my plate solve happens so fast. I don't want to tempt it to change it to anything else. Have you had good luck with ASTAP? What is it? All Star. I forget what ASTAP stands for. I have them all. I have Astro Tortilla. I have all three of them loaded on this computer. AS All Star Plate Solve, and I have ASTAP. You know what I'll do though is I will change it to that plate solve right now, and let's do something. Let's do a little experiment here, because I'm just fooling around tonight anyway. So let's turn live stacking off, and I'm gonna crank up my gain a bit here so I can get my exposure time down to like 2 seconds. Okay, so Tim is telling me this other one, ASTAP, is much faster. So we'll see. So here's what we're going to do. So I am going to do a new target. Let's find a new target. We'll do something close to where we're at already. So we will go to... Well, this star will be easy to tell. So we'll go to this star here. We'll move the scope over there. Let me turn guiding off, because that's going to kind of mess things up. All right, so now we should have that star in the center, which we do. We can see it, okay? But I'm going to do a plate solve with ASTAP. I forget what ASTAP stands for, but anyway, so it's solving. Oh boy, that was fast. Huh. It was 0.01 degrees off, so of course it made a correction anyway. But the actual plate solve itself was super fast. You know what I'm going to do? Let me bump this guy a little bit, and well. All right, Tim. Oh, So I don't know how far behind the stream is to what I'm talking to my buddy Tim here, who's messaging me on WhatsApp. But yeah, so I just switched over to ASTAP, and I already had both of them set up. I already had the catalogs for ASTAP installed, and I had the preferences set correctly for it. Because like I said, I've used it before, but in the past, it seemed like it was a little slower. But tonight, the first time around there that I just did it, it seemed much faster. So let me do this. Let's jump over to this star here. So I'm going to tell the scope to go to it, and we'll see the scope move, and this next star should pop up. So yeah, so I'll do another plate solve with ASTAP, and we'll see if it's, you know what I'm going to do is I'm going to bump it over just a little bit so that it's a little more off. Kind of really give it a test. Okay, so I'll hit plate solve. Let's watch the top left side here and see how fast it plate solves. Wow, it's almost instantaneous. Tim, thank you very much for the tip. That's even faster than Astro Tortilla or keep getting these acronyms messed up. So yeah, I was using AS All-Star Plate Solve, but ASTAP, boy, that is smoking fast. I am really liking that. Yeah. Okay, you rest. I see. You rest your case. Clear the other points you have. That would give it more of a challenge. I don't understand what you mean by clear the other points that you have. Are you talking about doing a blind plate solve? I never do blind plate solves because usually I've got CPWI talking to SharpCap here, so it kind of knows where the scope is supposed to be pointing, and it's usually, you know, within a, God, I hope it's within a degree. It's usually less than a degree. So tell me what you're talking about when you say clear the other points you have. I don't know what that means. Are you talking about clearing the RA and deck that's already in SharpCap here? Keep my little WhatsApp window open here now so I can see what's going on with our little private conversation we've got going on here. But yeah, Tim just gave me some advice. If you're using SharpCap Pro, you have the ability, if you're using SharpCap Pro, because I don't think in regular SharpCap, the free version, you have the ability to do plate solving. You may. I know you can't do polar alignment unless you pay for it, but plate solving may be available in the regular free version. Are you running ASCOM? I am running. It's my understanding, Tim, that in order for anything to work with the Celestron CGX mount, you have to have CPWI running in the background. That's my understanding. I wish I was incorrect. I would love to be told that I'm incorrect. But yes, I do have ASCOM fully loaded on the machine. But every time that I've ever tried to set up and use SharpCap where it recognizes the mount, it has to see CPWI. It looks for CPWI. So I don't know if that's kind of where you're leading at with that question. Yeah. It's just like, I know Software Bisque has to have the sky running in the background, like I believe it does. Somebody correct me if I'm wrong. Yeah, Celestron's a little strange. But you know, different mounts have their different little mount control programs that have to be running in the background. I know at one point in time when I was attempting to use Prism, Prism required CPWI running in the background as well. Okay, so my buddy Tim says basically every time you do plate solve, it tells the mount the information of where it is. Okay, all right. So I don't know how to go in and clear all of the previous, unless I went into setup. No, see, it even says ASCOM settings. Configuration is performed through the CPWI user interface. So let me go. I don't really want to start tinkering around in here with settings because, you know, it works great right now and I don't want to break something because I don't know what I'm doing here. I could go to configure mount. Let's see what's in here. I have never changed anything in this. I've never changed anything on this screen here, and I don't want to. I know you're wanting me to test it, but I'm afraid to, and I'm not gonna. Because I don't want to mess things up, Tim. Sorry. Let's go. It's under alignment. View pointing model. So no, that's That's all-star. That's Celestron's all-star polar alignment. So that's if you don't have Polaris visible, you can do a polar alignment off of any star. These are reference points to add to the pointing model, view pointing model. I'm not going to delete. I'm not sure what you're talking about. I don't want to delete my alignment because yeah, that'll just clear everything. That would be the equivalent of doing a blind plate solve because then CPW or SharpCap would have no idea where the mount is pointing if I delete my alignment. So I'm not sure what you're getting at there. It's kind of weird because it seems like the YouTube stream is about 35 to 45 seconds delayed. So you're asking me things sort of like after I've already kind of moved on. I see you talking in YouTube too, but YouTube is even the same way. I believe I believe when you're hearing me talk, like say right now, 1, 2, 3, you don't actually hear it for like another 30 or 45 seconds. So unless we were actually talking on the phone, I don't think there's still going to be a delay. I found that out the last time I went through the chat. Sometimes the delay is only like 15 or 20 seconds, but there's still a delay there. But Tim, I don't want to go into, I don't want to go into the settings and change this. I mean, here's the pointing model, but I haven't added any locations to create a pointing model. So that would be what that is, and this would just add reference points to the pointing model. This just tells it to sync on an object. I'm looking for, I really don't, the only time I use CPWI is when I connect to the mount, when I originally connect to the mount and tell it to go to its home position. And then that's pretty much it. I mean, I control everything from either Stellarium or, inside SharpCap here. I've got a little bit of control here too, so. But yeah, point very well taken though, and if anybody else is watching this at a later date, ASTAP is definitely much faster as long as you have the preferences set correctly. So it's All Sky Plate Solver is ASPS. So that's what I was using. I was using All Sky Plate Solver, and now I've switched over to ASTAP, which I'm not sure what ASTAP stands for, but maybe all star. I don't know. But definitely much faster on the plate solving. So we'll do another plate solve here and center that bright star back up again so people can see just how fast it is. It succeeded. It like doesn't even tell me that it's like scanning the files. It's almost like as soon as it downloads the image. Well, it moved it right back to where it was because I think I'm fooling around. I'm moving things around on my own manually here. So let's go to another star here. Let's go over to here. And so you can see the time here. So this is declination 3543 and right ascension 109. So if I go back over here, you can see that it's picked up a slightly different deck and RA, but very close. And the star is not quite center if I put the crosshairs on. But watch when I do the plate solve just how fast it is. I mean, I've never seen a plate solve this fast. Very cool stuff. I'm going to have to switch over to this plate solve. Boom, instantly. I'm going to have to switch over to this plate solve in Nina too for when I'm out in the field. Well, now that's interesting. It still didn't center the star up. I wonder what I actually chose. Did I choose the actual star or did I choose something nearby? Oh, I didn't choose the star. I chose an NGC object nearby. Oh, so there's an NGC object that's actually in the field right now. No, we don't want to do that. Close that. So let's go to the star itself. You can see the scope moving. I don't know why it has to fly so far away to just scooch over that tiny little bit there. So this must be the NGC object that we were just on here. That makes sense. Or that's a reflection, a filter reflection. Like this. This is probably a reflection off of that star. So I can go in here, zoom into this star, and figure out what that NGC object is. NGC 404, the Lost Pearl Galaxy. Interesting. Really impressed with this plate solve. See, the one thing I don't like about the Celestron mount is, or maybe have something to do with the plate solving in SharpCap, but it said it was perfect, and yet it moved it anyway and brought it back. If it's perfect, you know, don't move it. Leave it there. Alright, what's going on here? What are we going to do? We need to find something exciting to look at. The only problem is that there's not much that's very exciting in the light polluted, moon polluted skies that we've got right now. I'm kind of limited into the area of the sky that I can image. I don't think M81, M82 are quite up above the roof there, otherwise I'd go ahead and frame those up. Let's see. Well, we can go to the double cluster. You can see the mount moving over to the double cluster. Of course, I selected one of these are two NGC objects, and so I selected this one. If I had selected the other one, that one would be centered, and what we really want to do is we really want to center on something in between them. So here's what we'll do: we'll zoom in on the cluster here and pick one of the little stars that's sort of floating in between them here. So let's pick this star and go to that. That should center us up a little bit better here. There we go. Nice. Turn these crosshairs off. So this is the famous double cluster in the constellation Perseus. Tim, I don't know if you're still watching or not, but how is the music level? Is it, since you are probably my only viewer tonight, is the music mix good? Is it too overpowering? Should I turn it down? Should I turn it up? Did you even realize there was music playing? And you can talk to me in WhatsApp or in the YouTube chat. I can answer in either one. Of course, I ask for that request right as it goes in between two tracks. Anybody else is out there? Say hello in the YouTube chat. Thank you, Tim, for the feedback. I appreciate that. It is kind of mellow music. I actually bought this guy's album, and it's free to use. I mean, I forget what, it's royalty-free music. It's a guy called Simon Wilkinson. It's called Deep Space Ambient, and it's 54 minutes of music. It's like 10 or 12 different tracks that are super mellow like this. So yeah, I figured it was good background music for my live streams. It's royalty-free music. All right. Coming up on 8 o'clock. I've been streaming, well, my countdown started at 6:40 with a 20-minute countdown, but we've only been live for an hour now. I don't know what else I'm going to do tonight. I just felt like getting online. Let's do some 15-second exposures here. What have we got coming in here? We got a 15-second exposure. Oh, you know what? It's not stacking, and I know why it's not stacking. The instant is because my guiding is not on. I've got to start guiding in order for live stack to work, and that's what I found out because of this setting right here. I could turn this off, and then it would attempt to stack, even though PhD was not guiding, but because I have this on, because I want to dither, I have to make sure that I always have guiding going first before I start my stack. So that's our first 15-second exposure on the Perseus double cluster. Let's see. There comes the second one. If you have a telescope and you're just getting into astronomy, and even if you're not imaging, if you just are looking through the eyepiece, you definitely want to find this object in the sky. It is probably in a small telescope with a low power eyepiece. It is probably one of the most gorgeous objects in the sky to look at. You actually see two very distinct clusters of stars here, but it just looks like diamonds on crushed black velvet. I mean, it's just a gorgeous object. Mostly whitish, bluish white stars. Unfortunately, there's not a lot of color in the region, but that makes it even more look like stars or diamonds on a piece of black velvet. And if you're curious where it's at, we'll zoom out a little bit here. Most people can find the Cassiopeia, the W shape or the M shape of Cassiopeia, and it's if you just draw sort of a triangle off of these two stars here. My histogram drives Tim nuts. Let's go back to my histogram. Oh, because it's so far over to the right. I know. Well, I think that's because my exposure is probably too short. I mean, I'm sure if I bumped it up to like a 30-second exposure, it would push it way over fast. Don't you think? What if I do a reset? Yeah. It's not always like this though, Tim. Sometimes it's out here in the middle where it belongs. Sometimes it's over a little further on the right. I don't know what it depends on what I'm shooting, I suppose. Yeah, if you go back and look at my live stream from last week or so, look at the table of contents and look at you can go to like the final stacked image or whatever and look at the histograms, and the histograms are, I think, pretty normal, sort of in the middle, pushing the left hand side. Yeah, it is strange though, the way like this histogram is crushed way over on the whites on the white side here. I don't know why that would be. We could go through here and look and see if there's something that would give it away. Let's see. Alignment, star detection, black level threshold. I don't know what this does or doesn't do. Let's change it from 50 to 30 and see if that changes anything in the histogram. Well, new exposure just came in. It didn't seem like it did anything, so I am going to set that black level threshold back to where it was, 50, because if I can't see a change, I don't know what it does, then I am going to leave it at the default. Anybody watching this later and sees this, feel free to chime in if you have a suggestion as to why you think my histogram is so far over to the right there. I think it just has something to do with not using the proper exposures. Like I'm sure. Oh, you know what? I'm using 1 second. No, okay, 15-second exposures. I bet if I turn this up to, well, 30 seconds is probably going to. Is probably going to overexpose my image here, but it might also bring that histogram way over. Let's clear this. Let's start over. Let's start fresh. Live stack has been reset. I changed my exposure time to 30 seconds. And we'll see if the histogram gets pushed to the left any further. I would think that would be underexposed though, so it would go the wrong way. Yeah, see, it went even further the other way. So maybe my 15-second exposure is too much. Maybe it should be 10 seconds. And let's clear that and see which way it goes. Oh,